is now being recorded. Hello everyone, welcome to the last session of our EgQCC quantum security track. This is the fifth session today, migration and quantum risk assessment and strategy. Okay, just to recap, during the last 5 weeks, today is the fifth week, we covered the foundation of quantum security from physics and math and risk. And second session by Engineer Raghade, Post-Quantum Cryptography. Third session by our colleague Engineer Muhammed HelmY, Quantum Communication, Quantum Key Distribution, QTE, and Quantum Secure Direct Communication. This is the physics layer. And the last session, we are talking about cryptographic entropy. Cryptographic entropy is the source of truth. Today, it's time actually to know, after we covered all the basics, okay, we understand the problem, we understand the technological components from either from cryptography or from quantum computing. Now, how to do the migration and move forward. This is our target actually. So during the last 4 sessions, we are planning actually or preparing actually for today's session. Just to recap, very quick recap for the basic concept, a triangle of quantum security. First, we need quote-unquote cryptographic random or true random key. Then we should encrypt this key with a post-quantum cryptographic algorithm. Then we might actually communicate or transfer the key or encrypted data using quantum communication on a quantum channel. This is the first module, physics of security, the basics of quantum computing, the threat and the promise of security. Okay, the second session for post-quantum cryptography, different algorithms. And the third session, quantum communication, how we already exchange keys, data only. It depends on the QKD or QTA or QSC, like we discussed in the third session over a quantum channel. And the fourth session last Friday, cryptographic root of trust, cryptographic randomness, as simple as cryptographic randomness, just as a reminder, is non-deterministic physical entropy source. Full stop. Today, actually, this is what we are trying to do. This is our main objective and why we already we are preparing for this track. Okay, we know quantum computing is coming, and there are some threat models and threat attacks currently existing. Okay, what we should do in a nutshell, first thing actually is we need actually to discover what cryptographic assets or infrastructures that we have. We have assets data encrypted with cryptographic algorithms. This is CBOM or cryptographic bill of material. This is the first step. We need to understand what we have first. Then we assess the risk. Start with the highest risk first. We cannot do everything at once. Okay, so this is risk assessment or quantum risk assessment or post-quantum cryptography risk assessment, whatever you call it, on the level of the assets and level also of cryptographic keys itself, the random keys. Quote-unquote HSM, like we discussed. Then we start the migration and hybrid deployment, and this is the incremental cryptographic agile approach that we'll discuss. All right, this is a quick overview. Okay, let's start with today's session, quantum risk assessment. This is the quantum triangle of quantum risk, quantum security, as we discussed before. Okay, and this is the recap from first session, problem statement. Why actually, where these threats are coming from, and the Moscow theorem, x plus y greater than z. Actually, we'll use this within like 40 minutes from now in our quantum risk assessment. We use this theory, the migration time, and the shelf lifetime of data, and threat timeline, which is the Q day. We'll use this in assessing our quantum risk. Also, as a recap, this is not the first time we do a cryptographic transition or cryptographic migration, but there is a difference. This will be as you remember from first session 5 weeks ago, during the last 15 years, 15 years since 1970s, there was multiple or many cryptographic transition or migrations. And now actually we are planning to what we call BQC transition or post-quantum cryptography migration or transition. It is also cryptographic transition, but it is a little bit, I would say, a complex or a special case. So we can actually claim that our problem now is doing another cryptographic transition or cryptographic migration, which we call PQC or post-quantum cryptographic migration before the Q day. But it involves a lot of factors, so it is a little bit complex migration. So at the end of the day, this is cryptographic migration or cryptographic transition, but with multiple dimensions, multiple technologies, okay? And there is also multiple architecture approaches or patterns that we'll discuss. Okay, now we'll discuss some fancy words. Actually, we all like fancy words. Quantum threat models. Of course, we all of us actually know Harvest Now Decrypt Later threat model, which is a threat actor will capture both the keys and the encrypted data and store it now and encrypt it later. There are multiple variations of the same threats with different scenarios, but the same actually. All this actually are the same. Capturing the keys and the data, or only the keys or only the data, okay? And do something later, okay? So later actually is a common, okay? So Harvest Now Decrypt Later, actually, we already know it. I can decrypt the encrypted keys and decrypt and use it, decrypt the data, and reveal the classified information. As there is no also Harvest Now for later using only the keys or digital signature. This is applicable on digital signature, so I can have the digital signature or authentication information of the user, and this is a risk also. Harvest Now impersonate later, which is similar, using the credential for the user. So actually, I can decrypt this later and impersonate or that I am the user and log in the system using his identity. And also Harvest Now non-repudiation later. It is also related to digital signature, but signing the transactions or the digital contracts and liabilities. Also from some specific threats related to keys and blockchain, like break once, read everywhere, knowing the master key in blockchain, okay? This is specific scenarios for blockchain attacks, and retrospective blockchain recovery, the same also, okay? By the way, a major public blockchain network are doing or started planning for their BQC migration. They plan actually the published date actually is they should finish this migration within the next 2-3 years or something like that. So they're already a famous blockchain network actually started this BQC, and also this something related to physical security, hybrid and advanced attack threats, quantum assisted side channel amplifications using quantum computers, okay, to decrypt the physical keys using physical cryptographic chips, okay. And we all know the powerful of quantum computing, the rapid evolution, okay, is that in progress now. Okay, we also just a recap. We already summarized this actually in the first session 5 weeks ago. What is the standard the world is doing, either enlist in United States or European standard or China and the Middle East. So everyone is working on standards in BQC, preparing for this threat. So this is a worldwide coordinated activities, and of course there are different flavors. In our examples, we always use example from NIST and sometimes from European Union. Okay, but there are other work in progress in quantum resistant standards worldwide. Okay, what would be the first step? We'll start with what we can call quantum security readiness index assessment. If you remember the first session 5 weeks ago, we already had some sort of classification for the different organization in the world, starting from denial state to prepare to acting and doing the migration. So the maturity level, this is more or less self-assessment for the organization itself, without doing cryptographic bill of material or risk assessment or anything, just readiness assessment, okay, to identify if I'm unaware of the quantum threats, or just aware, or initiating, preparing myself, or planning, or doing the migration, or finish the migration. Okay, this is the 5 maturity level. Okay, and this is to the 8 dimensions that we should assess. Do we have a cryptographic inventory? Okay, for example, let's take hypothetical scenario. We are organization called ABC, okay, and we are now starting planning for the cryptographic, collecting our cryptographic inventory and CBOM or cryptographic bill of material. So level 3 here actually is planning, roadmaps, and some pilots, something like that. Okay, this is covers the visibility over where cryptographic is used in the organization. Where are my cryptographic assets? So here is 3, and the index here will be 9 actually. There are different weights. This is 15% of the total 100%. Okay, so there will be 3 actually. There will be scores. The total actually of out of 100. Did we do a risk assessment and impact analysis? Do I understand the criticality of data in different things, either data in motion and data at rest? We'll get actually to data in motion and data at rest when we discuss the CBOM material, because there are 2 types of data, as you all know. Data in motion, which actually we are using now actually during our session, encrypted using RSA, for example, over HTTPS and TLS. Okay, this is data in motion. Data at rest is stored on persistent storage disk or database and encrypted with something like ES or something. Okay, so there is 2 types of cryptographic assets: in motion assets, encrypting data in motion, and encrypting data at rest. We'll discuss this later in the second part when we discuss the bill of material. Risk assessment. Okay, for example, here I decided that I'm initiating. Okay, so this is my score. Do I have policy and governance? Do I have, so again, this is a readiness on the organization level mainly, a commitment of all the levels of starting from the top management to the all different departments towards BQC. Do we have leadership commitment and the strategy defined? So for example, here, level 2, initiating. Technology and crypto agility. Do we have upgradable or flexible cryptographic infrastructure for the migration? And this means, if you remember, all the different sessions that we discussed, especially in first session and second session, and maybe even third session, when we review sample code together, if you remember, we used implicit or hard-coded cryptographic algorithms in our code, right? Okay, this is exactly the opposite for cryptographic agility. Cryptographic agility means that I can change or replace or upgrade my cryptographic algorithms without changing my code, and we'll discuss this later. This is very important. The fifth dimension, migration and planning execution. Do we have a timeline and project plan and initial cost? Okay, so this is also initiating. 6 point, actually, vendor and supply chain readiness. And this is very critical because all organizations using either in-house developed applications or open source, and many actually uses a commercial application from external vendors. So the BQC roadmap for these vendors are very, very, very critical. So if I'm working with a core banking system, for example, and my core banking provider or vendor actually did not start his BQC migration yet, so I'm stuck with him. Regularity and compliance, are we aligned with our local regulation or not? And awareness and workforce training. Actually, what we are doing during these 5 weeks is we are covering this. EgQCC quantum security track is all about awareness and workforce training. We are trying to build awareness with what is quantum computing, what is quantum cryptography, what is risk and threats, and what we should do for the migration towards a quantum safe future. So, for example, in this hypothetical example, I already used put the highest level quantum safe readiness. This is the minimum we can start with, like we're starting now actually in our track actually, awareness and training. Okay, so with overall score 95%. So this is maturity, quantum maturity radar or risk index. Okay. All right. Let me switch to GitHub. Okay. Just a reminder. This is our GitHub repo. We have the presentation folders, as you know. Okay. And we have the code folder. Today, actually, strategy enterprise migration QRA. Okay. This is screenshot here actually in where it is. This is one. No. Quantum security readiness index. Okay. This is HTML file and also it is Excel equivalent. Okay. For this calculation, this is a README file for documentation, different weights for different factors. If you download this HTML file, I'm opening here right now. Okay. You will see actually just this is a sample actually simulator that I'm using. Okay. You can, for example, change this, for example, risk assessment to a planning, for example, and automatically you will have everything adjusted. And this is already the scoring guide. So again, this is quantum security readiness assessment or maturity, quantum maturity level. This is usually done by the organization itself, and this is the first critical step. So the organization needs commitment from the top management to start the BQC migration now and not wait to the Q day. Okay, of course, I remember that we already discussed, okay, should we start the migration now or wait for Q day? Of course, we should start now because the threat is coming. Remember, Mosca theorem, X plus Y should be less than V. Okay. All right. Where we are. Okay. So this is the first part. This is organizational level without doing anything on the my infrastructure. But again, this is very, very critical because without this, we will not have commitment for the top management in the organization or the government entity or the financial institute or whatever to start the BQC migration. So this is the start, and this is self-readiness assessment. And of course, as you see, it measures all the different factors or dimensions weighted, of course, to indicate how maturity is this organization or entity are ready for BQC migration. So this is the first step. Okay. So this was the first step. Okay. The second step is start building our cryptographic bill of material and doing the risk assessment. There are 3 steps only. First, actually, maturity, quantum maturity assessment or readiness assessment. Second, cryptographic bill of material or cryptographic inventory and quantum risk assessment. Third, doing the quantum migration itself. The quantum migration actually is a part actually that will take a lot of effort. So quantum risk assessment or doing implementing a services, actually, not self assessment model like the one we see for readiness, quantum readiness assessment. Building cryptographic inventory. I need to know first what cryptographic inventories that I'm using. Then PKI health check. PKI health check related to how I generate the keys, quote unquote, the random keys, if you remember last session, okay? Cryptographic random keys, cryptographic random keys. This is explicitly non-deterministic physical entropy forces, okay? This is the root of trust. This is the keys that I'll already encrypt either using or used to encrypt using classical algorithm, or now I'll encrypt using post-quantum algorithm. And this doing the risk assessment, okay? We'll now go to the CBOM first. This is the start of the work. But okay, before starting with the CBOM, okay, what is cryptographic landscape do we have? How many cryptographic algorithms exist in the world? Do I get any number from the team? This is a question for everyone. Do we have, for example, 10 cryptographic algorithm family, 20, 30, 50, 100? So is it in the order of tens or orders of hundreds? Anyone can guess?
We are talking about cryptographic families or cryptographic algorithms?
Families and algorithms.
Family, I think it's two, symmetric encryption and asymmetric, but I'm not sure about the number of algorithms. I think in the range of tens or hundreds, as far as I know.
I guess hundreds would be, yes, hundreds, because every family of them have multiple variants or flavors or variation. So a cryptographic algorithm and protocol, actually symmetric, asymmetric, hash functions, and key exchange protocol. This is very important. Digital signature and cipher switch like TSL, TLS, and SSL, very important, of course, and the cryptographic libraries like OpenSSL and others. Okay, so this is the families, okay, tens, like Karim mentioned, but actually each one of them actually contains many flavors and many implementations and many variations, so there is hundreds. Okay, so what is the typical size I would expect for a CBOM or cryptographic bill of material in a typical enterprise? Let's say a telecom operator or a financial bank, for example. Let's keep government and defense aside now. From real projects during many years now, an enterprise, medium to large bank or a telco will have hundreds of servers or virtual machines. Each one will contain something like 20 to 50 distinct cryptographic algorithms. So we are talking about order of magnitude of hundreds of cryptographic assets that we need to discover and document and collect. So this is not 1 or 2 or 3 or 10 or 20 or 100. No, it is 100 typically. And we have seen this in many projects. So this is what we expect. A cryptographic inventory typical size or volume. So what we expect, hundreds of unique algorithm implementation, considering the variations, the configurations and application itself and everything. So we are talking about a database table actually with hundreds of records. How to discover or collect this cryptographic algorithm? Remember that we have mainly data in motion and data at rest, okay? There is no single tool actually to discover all this cryptographic algorithms, but we'll start with, we have many tools like 10, for example, starting with static code analysis, like the example. All the lab exercises that we used, we used explicit static coding in our code, right? Of course, this is not a best practice from software engineering perspective, but of course, this is educational programs, so it is acceptable. But in practice, not recommended, of course, to hard code any variables or values or whatever, including the cryptographic algorithm that you are using. Use external configuration files and make this configurable such that when you change this later to an upgraded version, just you change environmental variable, okay, in all the environment without actually touching your code. So static code analysis to understand two things actually, and this is very important, two things. How random keys are generated in my code, very tricky. Second, what cryptographic algorithms and key lengths that I'm using, okay, both are important, okay. And also runtime monitoring, dynamic analysis. This is for data in motion, of course, and also network traffic analysis, configuration and file system scanning for data at rest, dependency analysis, what application or what systems interfaces with which system and which protocol and which cryptographic algorithm. Of course, network monitoring tool and SOC system and SIEM systems and tools like Wireshark, for example, or commercial SOC solutions, very useful in this type of analysis. And also binary analysis for the runtime itself when it's running. Also cloud environment scanning, hardware, firmware, and certificate key management discovery, which is HSM. So there is a lot of sources and a lot of places. Okay, imagine that you have the first external application layer. This is the proxy server outside, behind the firewall, and the web server and the application server and middleware server and application server and backend server and database server and all this layer, different components, including the network, the operating systems, the databases, all of this. So we have cryptographic components, everything, and hidden actually. You need actually to dig to reach it. Okay. Here is the right time actually to highlight one important point. We cannot do this all, okay? Capture all cryptographic data in motion, and also capture all cryptographic assets at rest, like database and files and etc. Okay, this is not easy exercise, but let me ask you a question here. Okay, harvest now, decrypt later. This is a threat model, right? This threat model acts on data in motion or acts on data at rest. In another way, actually, does it harvest or collect the data while it is in motion or from the hard disk at rest? Motion at rest.
I think it can work on both because it can get encrypted data while it's moving, like sniffing network traffic and so on. And also it can work by extracting encrypted data from databases or from whatever storage or whatever and keeping it. So I would say it should work on both.
Yes, but the majority will be data in motion because actually this is the common thread. External traffic, not internal traffic from data center, which is a little more difficult. So external is much easier. Everyone can collect the data, encrypted data. This is what is done currently, and this is data in motion, especially the keys. So the major threat service now is data in motion. So my focus in building cryptographic bill of material, I should start with collecting the cryptographic assets for my data in motion first, then data at rest second. Because actually, data at rest actually is a little bit difficult actually, because you need to check every database, every file system, every encryption vault actually to check how this data are encrypted and stored on disk. So just highlighting some priorities, because also network scanning tools can easily actually discover this data in motion and extract the cryptographic information a little bit easier, not that easy, but a little bit easier from extracting data at rest like ES. Okay, so why cryptographic bill of material is important? Okay, well, it is some sort of a standard, industry standard. Okay, it is as simple as detailed inventory, include all my cryptographic components from application systems and also IoT device. IoT device, especially a special case for PQC, because usually it has very low hardware capabilities and long lifetime. Usually you replace IoT sensors every 10 years, for example. So actually the migration is very costly. So IoT, PQC for IoT is a little bit sensitive area. Okay, so a special focus should be targeted to this. Okay, and the cryptographic bill of material provide some sort of holistic overview for my cryptographic landscape and my risk profile, so I can see and assess my risk. So it is very important, and also this should be built incrementally, of course, as we discussed, and maintained, updated with all updates, any new items or inventory items and my assets I added or updated, upgraded, introduce another layers. Okay, because this is a working record actually for regularity compliance and proving my progress. Okay, so for example, this is a very simplified. This is not detailed CBOM or cryptographic bill of material, but for example, I took some examples here. This is a web server, Nginx, using OpenSSL and RSA 248, okay, and TLS 1.2. And okay, I can add this later actually. This is not ready, we all know, and this is the recommended action. So the first part here is what is this component, business component? This is very important for risk assessment. This is web server, okay, not ready, okay. This is backend API, okay, using also RSA over HTTPS. This is a database. This is actually at rest. So this is in motion, and this is in motion backend API database using ES256. Okay. By the way, as we mentioned in the last two sessions, ES256 is considered quantum safe till now. Okay. Okay, till now, but this might change next year. So this is another reason that we need to focus on building our cryptographic bill of material or cryptographic inventory for data in motion assets. Okay, because of RSA threat and harvest now decrypt later threat model. Okay, and also another two reasons that collecting inventory information, crypto inventory information for data at rest, like ES for database encryption, a little bit will take some more time. Okay, and the last reason actually is till now, quote unquote, ES 256 is considered quantum safe, but this might change, of course, as we know. Okay, and mobile app and cloud key management system and the authentication system, for example, like OS2 and the login service. Okay, for example, actually, this bill of material is the starting point. I need to know what I have. Okay, what cryptographic algorithm, what libraries and tool I'm using. Okay, what key lenses. Okay, and what is the application here, because this will be a very important factor in quantum risk assessment. Risk assessment, it is all about how critical is the data here. So a web server actually does not contain critical data as such, okay? But of course, it exchanges the keys, so it is critical. Backend API is the same. Database, it is very critical, of course. It is where the data is stored. But logging service here, a logging service, encrypting logging information with ES128 This is not quantum ready, okay, and should be upgraded to ES256, like we mentioned. But does it, from risk point of view or quantum risk assessment, does it have sensitive data? Just a logging system for transaction logging and something like that. So this looks like that does not contain sensitive data. So this will be in our risk assessment, like we'll see in a minute. It will have a lower risk rating. So I'll put it, I'll give it a lower priority. So again, cryptographic bill of material is the starting point. Okay, so just to recap, the 3 steps that we are targeting in our quantum security track is do migration for post-quantum resistance cryptography. Okay, the 3 steps that we should do. First one, like we have seen 20 minutes ago, readiness assessment on the organization level, a commitment to start, because this is the usual starting point in any project, not only quantum migration or post-quantum cryptographic migration. Okay, I need actually to have the regulations and the buy-in from top management to move forward. Second, I need to build the cryptographic bill of material and do the cryptographic risk assessment. So this is the starting point, because everything is around CBOM. All the operations that we see now, assessing the risk on this cryptographic bill of material and doing migration on this cryptographic bill of material. Okay, so let's move to quantum risk model. How do I assess risks? Okay, you will have this Excel sheet, by the way. The detailed sheet here for this one. Okay, in our Git repo, you will have this sheet, this Excel sheet. Okay, EgQCC risk models. Okay, is Excel sheet here in our repo. Okay, so don't worry. Actually, if you cannot read the details here, but there is a lot of quantum risk models. Okay, any one of you actually worked in GRC before, governance, risk, and compliance? This is more or less GRC exercise, governance, risk, and compliance. Okay, chat. Okay, I need to start with a risk model. Okay, and the standards, regulation, and assess myself against this risk model and the standard. Risk model is how to calculate my risk according to the standards. So we'll find here at least something like 10 risk models. Okay, like Mosca theorem itself. Okay, the famous Mosca theorem. This is binary, pass or fail. Okay, but there are derived actually formulas based on Mosca theorem, Mosca inequality theorem we'll use now. Okay, in this quantum adjusted risk score. Quantum adjusted risk score used 3 factors regarding the timeline and the sensitivity of the data and exposure of the data in respect of how we stamp the crypto later, and provide a score or index from 0 to 1. Okay, we have crypto agility risk assessment framework. Okay, it calculates risk based on time and cost only. We have quantum ready architecture for security and risk management, and this is mainly readiness level. Okay, and we have one FS Isaac. This is financial sector specific, stochastic and probabilistic scenarios for calculating risk assessment. Okay, anyone's working in financial services, Isaac, FS Isaac actually using in scoring risk rating and scoring calculations include some probabilistic and scenarios. Also the same organization has already EgQCC risk model based on statistical scenarios. We have quantum encryption resilience score. We have IBM quantum safe readiness. You have migration readiness score. We have post-quantum financial infrastructure framework, also financial sector related. We have Scout framework, likelihood aggregation, and impact index, and we have something fuzzy analytical hierarchy for quantum communication mainly, and QKD infrastructure. So there is a lot actually. Here is a summarized version. You'll also find on the GitHub this part. Okay, foundational models, risk models, and advanced quantitative like Mosca. Okay, and Karab, and pragmatic threat identification, and CARS. We actually will use quantum adjusted risk rating because it include multiple dimensions and have some tangible values. Okay. So the conclusion here is like GRC, their geographic region or their country actually will have some standard and regulation, like ISO standards, like NIST standards, like HIPAA standards in healthcare. And we'll have regulations, okay? And actually, based on this, all the regulation, like, for example, we are using here actually some of the famous current regulation, like DORA from EU, Digital Operational Resilience Act, and NIS2, Network Information Security Directive from EU as well, and Norwegian Security Framework, and the NIST PQC, for example. Okay, so this is example for the regulatory mapping that currently exists. There are a lot, of course. Okay, and this is the variable x plus y should be less than z. Of course, you know this, for example, and this is the main elements that in the CBOM. Again, the CBOM is actually everything is around all the operation and calculations, either in risk assessment or in migration, will be around CBOM. Algorithm type, key size, تمام, protocol, PQC status, and migration, and asset dependencies actually, and what other systems depends on it. Okay, in Mosca theorem, this is a variant of Mosca theorem actually called the Mosca inequality, and where we use the ratio of x plus y over z. Okay, how we'll do this? This is a calculation part. Okay, I already choose this actually because it has some clear and straightforward calculations and numbers and risk ratings, and also it's becoming very popular. But like we said, there is at least 10, 20, maybe 30 now of quantum risk models that can be adapted according to each standard in each geography or each country. Okay, so we selected this as one popular example, quantum adjusted risk score. 3-dimension, time, T, sensitivity, risk, S, and exposure risk, E. So T and S and E. Timeline risk based on the formula, Mosca ratio, X plus Y over Z, okay? And you calculate T by this complicated formula, okay? And this is usually results in 0 to 1 range. Sensitivity risk, this is a factor. 0.1 is low, 1 is very critical, and anything in between. How much my data is sensitive? Remember, in the sample CBOM, allowing server does not have sensitive data, so it will be most probably 0.1. But a core banking system will be critical or at least high, something like that. Exposure risk, this is regarding how it is, how harvestable it is. Okay, so it is multiplied V by Q. V here is a variable. It is 0 if it is not BQC protected, means that it your classical algorithm, and 1 it is it is 0 if BQC protected, and 1 if classical algorithm. So if it is this RSA, so this will be 1. If BQC would be 0. And the Q, harvestability factor, 0 and 1. This is also judgmental because how exposed this asset okay, to harvest now the crypto later. Okay, again, I'll return now to the CBOM example. Okay, we are doing this quantum risk assessment line by line. Okay, we are calculating a risk score for each asset here. Okay, so for example, typical CBOM size will be hundreds, 500, 1000 CBOM. So we need to calculate actually the risk rating or risk score for each CBOM, for each line in this inventory. Okay, and we can get, of course, an overall average risk score, but it is also important, very important, to get itemized risk rating per item. Okay, so this is the calculations. Okay, this is how T is calculated, time risk, how sensitivity is calculated, S, how exposure, E, and then the final score is the weight of T multiplied by T, weight of S multiplied by S, and weight of E multiplied by E. So here we have T and S and E actually. What is the weights? The weights in the next slide. Okay, there is some empirical factors. For example, in the financial sector, the time dimension will be 40%, sensitivity 40%, exposure 20%. The rationale here is regulatory pressure, transaction integrity, for example. For example, cloud services will be 30% time, 20% sensitivity, 50% exposure, multi-tenancy, shared infrastructure risk. Why actually here in cloud infrastructure, exposure risk is 50%, much, much higher, with respect to harvest now, decrypt later? Anyone can guess? Because it is harvestable, actually. It is actually a public cloud services. So it is exposed to internet. So probability of someone actually can collect the traffic or harvest the traffic actually is much higher. Again, this is empirical values from best practice and configurable, of course, and should be adjusted or tuned based on each country or each region or each even organization. Okay. This is example risk score, risk rating. So if I have the final score from 0 to 1, so if it is from below 30% will be low. Okay, just put it in the normal plan. If it is over 85% critical, so this immediate action. Okay, more than 60%, no, you should do immediate assessment and the plan forward. So this is the basic calculations. Okay, and this is the weights. This is sample risk portfolio, for example. Core banking system, if you do actual assessment, you will find something like 90%, which should be critical. Okay, and of course violate MOSCA status, and which means that you should act immediately. Identity provider, IAM service, for example, cloud, right? Critical also. Payment gateway, finance, high. Okay, might be safe. Keep it for the next year. A smart meter infrastructure, IoT, high. The violation, you should start the planning. Serverless function. Okay, this is very good example. Serverless function. Serverless function mean a serverless image does not contain any data actually on the cloud. So this is typically like exactly the logging example. The risk scoring actually will be very low. Okay, and this will be safe because not because it uses BQC algorithms, but because it does not have any sensitive data. It is serverless, so meaning that does not keep any sensitive data in it. So this is why the risk assessment is very important, because the typical size of CBOM or cryptographic bill of material will be very huge for both, either for data in motion, which is the most critical now, and the data at rest. Okay, and I should do migration plan for 100 assets or 1,000 assets or whatever. Okay, I can do it. I cannot do it actually at once. So I need to plan it on phases. Okay, based on the risk priority. So this risk assessment is very, very important for two reasons. I need to understand my current risk, okay, and base my migration plan accordingly. So start with the critical things first. So this is very important. Okay. Also, you will okay in the GitLab you will have quantum adjusted risk scoring here. You will have also HTML web single page web application file, and this is the documentation for the quantum assisted risk, quantum adjusted risk scoring, the CARS, starting from foundation model for Moscow theorem and T and S and E, with different typical weights for their industry and calculation formulas with examples, typical risk scoring and regulatory alignment. This is what you should do, okay? And example calculation formulas, and we will find it here actually in this. So this is single page. This is HTML file on the repo. You will find here sample assets, I guess 18 repopulated assets, for example. This is asset information. This is payment gateway API, data shelf life and X10, migration Y 3 years, threat horizon 2 day Z. Okay, so this is the three main parameters, but also here is actually the two factors for the Q, V and Q, if you remember. V and Q in harvestability. Okay, so for example, okay, again, risk assessment or risk scoring should be done per asset. So this is, for example, this is the current the payment gateway API, for example, as an example, just example, has 0.79 risk score or risk rating. What if I can do the migration within, instead of 3 years, I'll change this to 2 years. I change it Y to 2 years, so it already decreased from 0.79 to 0.77. Okay. What about, this is 10 years actually, we're talking about 2030, 2035. What about if the time horizon or the Q day is 15 years from now? What do you think will happen? This is just, by the way, this is simulator actually for playing with the equations only, or understanding the equation. I'll increase it gradually to 15 years. You see what happens? Lower risk, okay? And also here, this is 30, this is the S actually. This is critical asset. So if it is medium, for example, of course, much lower risk. Remember the serverless cloud service, okay? So this is very good. This is the sensitivity, that this is high. But of course, API gateway is critical, okay? And also the last part actually is the BQC. Is it, this is done BQC. So this uses classical algorithm, which should be something here, RSA, for example, 248. Okay. But if I did the migration, okay, this is classical, this is BQC, this is classical, this is BQC. Okay. So this is also some example also on just to play with. Okay. And also you will find it here in the same Git repo for a strategy and database migration. Okay. So we are talking about migration. Okay, let's move to the third part. Okay, so what we discussed so far. Okay, today is the 5th week in our quantum security track, which is actually we can call BQC migration track, post-quantum cryptography migration track. Okay, because our objective is to migrate to post-quantum cryptography. Okay, why? Because the coming quantum threats. Okay, so the 3 steps already that we already discussed, we covered 2 so far. 1, start doing self-readiness assessment to get the buy-in for the top management to start the BQC migration. This is the most critical part. And this is self-assessment. Okay, do you have a commitment? Do you have resources? Did I start planning actually? Did I start awareness? Did I have a committee actually responsible for this migration project? Okay, again, remember that a BQC post-quantum cryptography is more or less a quote-unquote complex migration project. Okay, we'll explain later actually why it is complex. Not because of the number of assets, because of other architecture aspects. Okay, and then the second part is building our cryptographic bill of material. This is the first. You cannot move one step without CBOM, and with the CBOM come risk assessment or risk scoring. Each cryptographic asset, you need actually to document in which business domain, what cryptographic algorithm, what is key length, what is cryptographic tools actually that or platforms that is using, okay, and what is the stability of data harvestability, okay, and the criticality of this asset, okay. Based on this information, like we have seen in quantum assessed risk scoring, we can calculate actually the risk score for each asset and start putting our migration plan. Okay, so what we need actually is hybrid strategy. Okay, now we are moving to the third part. Okay, doing the actual migration. Okay, now we are ready to start our BQC migration. Okay, and we should have the majority. You will not, by the way, you don't need to wait to collect all your 1,000 cryptographic assets. If you have 1,000 cryptographic assets in your organization, okay, start focusing actually with the assets that encrypt or protect data in motion first, okay, and as soon as you have 100, 200, 300 asset in your CBOM, start to doing risk assessment and do the planning. Don't wait to collect everything. So it must be in parallel, and this is the hybrid agile approach, okay? And then put the high priority, address the need for quick action, okay? And also put long-term security focus, okay? So you need actually to do your migration plan, okay? Taking into considerations immediate actions that need to be taken, and also short and long, mid-term and long-term plans, okay? Now, the tricky part, okay? Cryptographic agility. Cryptographic agility, okay? This is exactly what I meant actually by when I mentioned all our lab exercises or lab examples, or the code actually we are doing in research R&D, okay? We use explicit hard-coded key generation, random key generation, quote-unquote random, pseudo-random, of course, as you remember. And also explicit cryptographic algorithms, either classical or BQC, okay? So cryptographic agility means very simple thing, okay? I should be able to change cryptographic algorithm without, okay, changing my code. So this should be plug and play like any upgrade or any normal software, okay? Why is this? And is there something actually, any middleware or software or applications now or systems can claim to be cryptographic agile? Yes, the answer is yes, of course. Of course, you remember the standards, okay? PIPS 200, 203, 204, 205, and coming 206 for digital signature. was published late last year, something like that. Okay. When do you expect the new update for FIPS 203 and 204 and 205 to be published? And it took something like 10 years from 2016 to last year, something like 9 years, almost 10 years, to publish the first standards. Okay. One would expect actually something like by end of this year, we'll have enhanced version of FIPS 203, FIPS 203-A, for example. And maybe next year, we'll have something like FIPS 200, 203, or 2033, something like that. Okay? Is this something we should expect? I guess yes, because if you remember the cryptographic transition history during the last 15 years, the changes in cryptographic infrastructure was not that fast. Every couple of years, 5 to 10 years, actually, new algorithm or new version or new approach. Okay, but now with BQC, it is ongoing every month actually. So everyone is doing research in BQC and doing also testing, and new vulnerabilities are already discovered every day, even in FIPS 203 and 204 and 205. So this is the second reason that I should have this cryptographic agility. Okay. The top two examples I personally like, OpenVPN and OpenSSL. Okay. This is open source VPN, OpenVPN, and OpenSSL, also open source SLL. There are commercial equivalent, of course, actually. But what happened maybe more than 2.5 years ago, that both OpenVPN and OpenSSL migrated to BQC algorithms 3 years ago. Okay. If you notice here, actually, this was before the new FIPS standard, which was last year. So they started doing the BQC migration on even the beta version of FIPS standards by NIST. Okay. And what they are doing is with each new release or candidate release or pre-release by NIST, they put it just an upgrade. So when you run OpenVPN, okay, you have, okay, there is a new release, you want to install it, click download, install, click, up and running. So you have OpenVPN upgraded and migrated to the latest BQC algorithm. OpenSSL is the same. This is exactly what we mean by cryptographic agility. Okay. If this is clear, let me ask you a question. Okay. If you have a system legacy application, old, mostly not using the best practice of software engineering, and uses hard-coded random keys and cryptographic algorithms, would this be a problem, and how to make it cryptographic agile? This is the $1 million question of today, actually. And this is really the name of the game, actually. This is the main thing, actually, here. It is not just a migration. Okay? It is migration and rectifying or retrofitting my cryptographic infrastructure to be agile. To be agile means that the evolution of quantum cryptography and post-quantum cryptography is moving very, very, very fast. So I cannot afford to do migration, for example, later this year or next year, and redo it again, actually, after 2 years, because actually the race is ongoing. So cryptographic agility is a must here. So this is one dimension, and this is very, very important part. The second part actually is hybrid migration. Hybrid migration, of course, this is mainly to mitigate the immediate risk, like harvest the crypto later. Okay, this is intermediate steps, okay, to combine both classical algorithm and post-quantum algorithms, like Gerard explained in second session for BQC. I use composite key that already uses both a classical algorithm and the BQC algorithm, okay, and they will be backup to each other. So this is a hybrid approach, okay. So using hybrid keys, okay. From architecture perspective, there are three architecture pattern or three paths, okay. This is in order of simplicity, okay. The first and most straightforward part is what we call the proxy pattern. Proxy pattern here, if this is the client layer and this is internet facing, okay, I usually put some proxy server layer outside my existing component, okay, that will communicate using BQC in the outer side and isolate my internal systems from outside world, okay. What I did in this case is that I immediately provide protection against the threat model of harvest now, decrypt later, because any threat actor trying to collect this traffic, it will collect a traffic encrypted with BQC, because I simply put a proxy layer, okay, isolating my critical applications from external system, and this will be encrypted with BQC algorithm. So whatever collected now, actually it will be collected, encrypted with BQC. So this means that at Q-day, it cannot be, theoretically, quote unquote, cannot be decrypted using large enough power quantum computers, okay? And this is the first crypto pattern, architecture pattern. And this is also can be called hybrid migration. Yeah, hybrid approach here, using hybrid keys and also using hybrid infrastructure. So introducing proxy pattern here. The second pattern is doing full migration. So I take all my system components and migrate all RSA and elliptic curve and ES to BQC algorithms. So this is a lot of work and need a lot of planning, of course, but it must be done, but will take some time. Okay, so till we do actually the full migration or the upgrade pattern, I can start with the proxy pattern or the hybrid pattern. And the third part is securing key short distance critical components with QKD or quantum communication. So you can find actually all the details here also on the GitHub link. This is the file called The Architect Guide to Quantum Security. This is a white paper I personally like because it explains actually this three architecture pattern for BQC migration. Okay. And this is, I'm not sure actually why it is not readable, but it should be opened. Okay. Maybe network traffic or GitHub. Okay. But it contains actually this architect guide to quantum security actually contain all the details of this architecture pattern. Okay. And this is what makes this BQC migration is a complex migration project, because I'm not just replacing cryptographic infrastructure or algorithms or keys. No, I'm changing my architecture as well. Again, just to make sure that this point is clear, I'll just go back to the slide of historical cryptographic migrations. Okay. Remember this slide? Okay. From 1970s, during the last more than 15 years, there was more than cryptographic transaction, but each one was something like 5 to 10 years. It was not moving that fast, but this has changed, okay? Because since since 216 or maybe 215, NIST already started working on the BQC algorithm. And finally, this was not last year, 224, published the first BQC standards, okay? 1.5 years ago, okay? What is happening now is everyone is testing these new standards and even developing new standards and discovering vulnerabilities. And instead of waiting a couple of years, many years actually, till a new version of encryption published or developed, no, we can expect that every year, if not every couple of months, that we have a new update in BQC standards, either from NIST or from other regions. This is NIST only, but actually it is not NIST. Actually, it is Europe, China, and Middle East. Okay, so this is what makes this BQC migration is a little bit complex, because I need actually to investigate or discover, okay, as is cryptographic infrastructure and building cryptographic bill of material, okay, documented very clearly, documenting the as is architecture, because I need actually to draw, if I don't have real architecture with real traffic between system components, okay, I cannot actually draw architecture like this and cannot plan actually the migration correctly. Okay, this is very important. Okay, second, you will find this cryptographic algorithm in many locations, some of them hard-coded. And this is very critical, or very tricky. So part of this PQC migration is cryptographic architecture migration as well, or rectification. And this is what it makes it a little bit complex. And it is really very complex, because if we did not do this, what will happen is I might have to repeat the migration every 1 year or two, which is a lot of cost and time and money and resources, of course. So it is a critical migration project, should be planned carefully, but it is not only migration, it is only architectural rectification of my cryptographic infrastructure. All right. Any questions so far?
Yes, for me, I have a couple of questions. Can I ask now, or?
Oh, sure.
So my first question, if you can go back to the crypto agility part, yes. So when we speak about crypto agility, are we speaking about just changing the algorithm, or are we talking about so for example, we're using let's say we're using MLChem, and then we decide that we want to use EgQCC, or we need to go to a different algorithm, or are we talking about changing the way that we are communicating? So we're using OpenSSL and in our libraries, and we need to go to a different library. We found that there is a vulnerability here, or we're using. I'm not able to think of another approach, or another way, but I'm just thinking. Are we just talking about changing it?
Actually, both, and maybe more, actually. You need actually to be ready to change your RSA replacement algorithm, okay? And also replace TLS or upgrade to the newer version of TLS, both. Okay. So let's take an example. let's take an example from any sample codes that we already explored together. Okay, let's go to get I'll try to open this to make sure that it is available. Okay,
I think you need to open it from outside GitHub, so probably you need to download
yes,
it and open it.
yes. I'll just do this check because this white paper is very, very important. Okay. Okay, I'll download it to desktop. Okay, and open it from here. Okay, it is correct. Okay, great. Okay, this is a very nice document by Forster, I guess published last year, something like that. Okay. This is the introduction that you already all aware, actually, and here is a part of not only migration, but mainly re-architecture of your cryptographic infrastructure, adding additional layer and already modifying your cryptographic infrastructure, starting from cryptographic libraries like OpenSSL, for example, and TLS, proxies, okay, orchestration layers that already handle, because of course, not all clients will use EgQCC algorithms, so you need actually to support hybrid cryptography, and also all integrations. Okay, this is the first part. This is the proxy-based pattern. Okay, and this is the upgrading pattern. Everything will be upgraded, which is a lot of work. And third part was QKD, but only for special or key communication. So this is okay. Now what I wanted to do actually is to take some example, maybe from first session, which is the triangle of quantum security. I guess we have sample notebook here. We're just doing very simple things. Okay. And one of the things that we were doing is expressly, of course, you remember, actually, this is the random seed course. If you remember, where is the part that where we generating the keys? This is random. Okay. Okay. EgQCC, for example, lattice based description. Okay. 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 Here actually expressly actually identifies the parameters for the algorithms. For example, something like this. Okay. This is what good example to discuss. Okay. Here, what I'm doing here, this is not the best practice from software engineering perspective, but here in my code, okay, I'm specifying the algorithm and the parameters for my cryptographic algorithms. Okay. So I'm using Kuiper here, for example, and currently this is okay. What happens if a couple of months or next year I needed to upgrade this? Okay, so if you remember from part of CBOM discovery or the approaches to build cryptographic bill of material is static code analysis. Static code analysis, usually in cybersecurity and pen testing, actually we look for vulnerability in libraries used and variables and memory management, and of course, but in our EgQCC scenario, actually we'll be looking for any explicit key generation or cryptographic algorithm, okay, in my code, as part of static code analysis. And one of the migration, actually, that's why it is complex. One of the migration parts actually is I should convert this actually to move it to external module, plug and play. So every time actually I need to change the key length, the key source, the algorithm type, actually just doing an upgrade. Okay, so this will be just a normal upgrade without changing in my code. So this is the first part of what we mean by cryptographic agility. Okay, and this is very tricky, by the way, not that easy. Okay, the second part for cryptographic agility is the pattern itself, introducing some additional components or additional layers to control my environment, okay, and make this on the middleware level, like TSL, for example, or OpenSSL, upgradable as well. So this is second part. Okay, did I answer your question?
Yes, thank you. Another question.
And this is
When we
not
talk
easy. Then is it,
oh, I know. I just wanted to understand the scope. Okay, and I'm not happy that I understand the scope. Okay, so
exactly. Yeah.
my second question is, when we speak about hybrid migration or hybrid keys, are we saying that we'll be using both? So are we going to use both of them at the same time, or we'll use the classical one or the PQC one? So to be able to do backward migration, or for partners that do not upgrade, they use the classical approach, and for partners that upgrade, use the PQC. I'm not sure I understand exactly. I'm not. Do you understand my question, or
Yes, and that's my questions actually. And I guess we have one of our attendees here, Shahd, actually, is doing a graduation project in eJust, doing exactly this. Shahd, would you like to answer this? I can answer in love, actually. Actually, the proxy layer, okay, the agile proxy layer actually will have this intelligence. It will support, for example, we have version of Nginx and Apache Tomcat and all application servers that can work as proxy, can support both types of cryptographic algorithms. So from the clients actually communicating using classical algorithm RSA, it will interact with it actually using RSA. If any of the clients actually connecting using PQC, CHEM, for example, it will interact with CHEM. Okay. Internally in the background, the traffic here actually will be encrypted by dual key, composite key, using two keys concatenated, RSA plus CHEM, for example, something like that. Okay. Having that said, the latest survey, I guess last month, 41% of the top 1 million domain are supporting hybrid PQC right now, like Cloudflare, for example. So this is not a small ratio. It is not 100%, but it's not small. So the top 1 million domain, like Google, Cloudflare, all the top 1 million actually, 41% of them, as of last month, support hybrid PQC. So if my client or my browser or my application actually communicating over CHEM or FIPS 203, it will communicate with it actually over PQC. If it uses RSA over TLS, older version of TLS, it also will communicate. So this is already happening, not as fast as we dream, but it is already fact of life now.
So maybe I misunderstand this, but so my understanding is that the certificates itself are not upgraded yet. So how, or at least the intermediate route, technically we can generate certificates using OpenSSL or whatever, using whatever key and generate it, but we cannot sign it. So how is this working? How are we have providers or have domains that are using PQC, but they're using the old certificate? I'm not following what's happening here.
Using both, for example, Cloudflare, for example, this is one of the 41 sites in the top 1 million domain. Okay, so Cloudflare, for example, what it does now, if this client actually using TLS 1.1 older version and RSA, okay, and accessing a site actually on Cloudflare, it will actually fall back to the compatibility mode and respond to it and exchange RSA over TLS 1.1 or 1.2 as usual. In this scenario, of course, this traffic is subject to harvest now decrypt later, right? But there is another client actually using TLS 1.3, okay, and BQC algorithm, and communicate actually all the traffic between both of them actually will be using BQC keys, okay? Where is the hybrid? The hybrid in this layer actually, in this part of the traffic, okay? When I communicate with my other systems, so there is no two scenarios. The external clients, okay, it depends actually. I don't have control on them, so I should support hybrid protocol, but one at a time, okay? But in my systems internally, like these lines, for example, if you see my the cursor, okay, I encrypt all my data in motion with the hybrid keys. Because
Yeah,
this is our let me show you a code example. Let me show a code example. Just opening this right now. Code example. It is very, very, very simple. Where it is? This one. Okay. This code. This code, for example. This is what I use internally between my system nodes, not external public nodes or clients on the internet. I generate classical key, for example, then generate BQC key pairs. Then my final key will be combining both, something like that, concatenating. This is the other type actually. So there is a multiple definitions here. Okay. Okay.
And when you decrypt, what? So I'm just trying to think of.
This is my, okay, I'll switch to the presentation, okay? So this is not from the internet layer here, okay? The internet layer either classical or BQC. So this hybrid proxy layer or agile proxy layer actually should speak the two protocols or understand the two protocols. But from within my systems here, actually, I do this actually between my node and this node, for example. So I upgrade this, okay, and also put some layer here, additional layer wrapper, by the way, to translate this. So this link will be protected also if anyone try to collect the data. So the data collected here will be dual encrypted with a composite key like, or concatenated key like we have seen, which is the classical key plus the BQC key. This is one scenario. There is other scenarios, by the way. But this is one of the popular scenarios. But this will not need actually a modification or upgrade, because this is a hybrid agile proxy layer, speaks all the protocols, classical and BQC, and in all my nodes, actually my system, I just modify the wrapper actually, or the interface. Just add additional interface, okay, or translation layer to accept this new hybrid keys. So this is one of the approach.
Very clear, thank you. I think that the proxy pattern is the most suitable, or at least the quick fix that can be done, and then the upgrade
Yes,
can be done
exactly.
internally after that. Yeah, so,
Exactly, because of the timeline, like we'll see actually within a
mm,
couple of slides so far.
mm,
Okay,
mm. Thank
I
you.
guess this will be okay. The slide actually you will see the timelines. That's why yes, the hybrid proxy layer actually is very recommended, or the hybrid approach, because the full migration will take time, because it is not only migration, it is a lot of work on rectifying or correcting or adjusting or modernizing my cryptographic infrastructure. Okay. Okay, let's try to summarize actually the steps that we need to do. That's why it is complex migration project. Okay. The preparation part, we should build knowledge about BQC algorithm. Okay, you will notice, by the way, this is what we are doing during this 5 weeks for now. Okay, we need to build our knowledge. What we are doing actually during the last 4 weeks and today is the 5th week. Okay, we are building our knowledge about quantum security, BQC algorithm, quantum communication. Okay, you need to have this logic, which is combine both cybersecurity and cryptography, as well as quantum cryptography, like BQC and QC. Okay, so this is very, very important part. This is what we're trying to do during the last months. And then actually building or collecting inventory data. Okay, the simplest part is to start with data emotion. Okay, because this is immediate risk for data emotion like RSA. Okay, because quote unquote ES256 is considered quantum safe till now. Okay, so we should focus on RSA and the elliptic curve. Okay, and put it as a priority. Of course, ES and data at rest actually is priority, but will be second or third priority. Okay, and also with all the middleware and protocol with level of sensitivity and everything, because we are, as we discussed, we are not building inventory asset management for our cryptographic systems, but also we're describing business environment, data sensitivity, data exposure, shelf lifetime, all these parameters that are used in risk scoring and risk assessment. Okay, and then using this personalization, using Mosca's theorem, lifespan and quantum exposure Q day. X plus Y should be less than Z. So if I know X and Y and Z, this will be parameters in risk assessment, and also other parameter for sensitivity and exposure. Okay, so I am building, assessing the risks. So again, to summarize, if I have 500 cryptographic asset, I need actually automatically, I need to calculate the risk factor or risk score for each one of them. Of course, I'll have, in my dashboard, I'll have one overall average, but it's okay, weighted average, which is okay. But I need per item or per cryptographic asset, I need actually to know the risk rating or risk sensitivity or scoring to put it in the right priority. This is very important, because when I go to the implementation part, okay, I'll start with the vulnerable or higher risk first. So risk rating of 0.8 or 0.9, okay, I'll start with it immediately rather 0.7 or 0.6, okay? So I'll start doing some penetration testing, code reviews, and all the other techniques that already we discussed previously in discovery of my cryptographic inventory, okay? And the problem here is that any typical system, you will have a combination between mainly 3 types of software stacks. Either legacy home developed applications, okay, from long time using older technology. And typically from my personal experience, actually, what you will find is you'll find hard-coded actually parameters and variable for everything, including cryptographic information. Okay, this is part. You need to discover this, and you need to do some plan for migrating this, which is very difficult. Second part will be open source stack. The open source, if you are lucky and you have open source component in your infrastructure, this will be the easiest part because almost all open source stack in the world actually has already moved to BQC because open source community is very fast. So as an example, actually, which I like, OpenVPN and OpenSSL has already moved to BQC since more than 2 years now, even before the final publishing date of FIPS standards. Okay, and what they are doing now is whenever new standards or new release, the follow NIST, of course, by NIST actually is available. Actually, it is just another very small upgrade for OpenSSL or OpenVPN. So if you are lucky and you have open source technology stack, so almost you don't need to do anything. Okay. The third actually scenario, actually, if you have commercial products like core banking applications, like commercial database systems, in this case, you are okay. You have actually to depend on the third party or the vendor and his BQC roadmap. And this is very, we have seen a lot of problem currently because many of the vendors actually either did not start or started or just delaying. They don't see immediate a need, but this is very, very, very important, very critical. And if you remember, one important thing, sorry, I'll just briefly go back to the readiness index here actually to highlight this vendor supply chain readiness. This is very critical, very, very critical. Okay, that you need to ensure that your partner and the products, commercial products, are already have BQC blend. Otherwise, you are stuck. We have seen many situations actually facing this. So again, if you are lucky and depending on at least part of your infrastructure on open source stack, you will be very, very lucky. You don't need to do anything. So there's 3 scenarios here. One of them is very, very beautiful, actually, utopia. Open source, actually, you don't need, you're already BQC ready, all right? And by the way, actually, in our organization, we are already adopting open source strategy and everything since last 20 years. So actually, almost all our project now actually is BQC ready without investing much effort, actually, okay? The second scenario is legacy code with hard-coded. So you are, okay, you need to do a lot of effort for this migration. And this is typically, as we know, a very difficult exercise because sometimes you don't have enough documentation. The migration itself, code migration itself from legacy old system to a newer modernization, okay? This is a modernization project, including the cryptographic infrastructure component, which is usually not that simple. The third part is it depends on your vendors if you are using commercial components. So one of the things actually that must be done in any organization is to start immediately doing 2 things actually. When you plan any new projects, you just put in your specifications that any new solution will be BQC ready. In this case, actually, you will start enforcing or encouraging your partners and your vendors to start working in a future BQC solution. This will make you avoid a lot of cost later. So this, was there any question? Okay. And this is the second critical part, crypto health check, BKI, public key infrastructure readiness. Okay. BKI readiness here actually is as simple as HSM, hardware storage management, or the random key or certificate authority. Okay. You remember last session for cryptographic randomness? Of course, in the code examples that I showed you before, I used the pseudo random code generator in my code. So part of a static code analysis, okay, you have 2 scenarios here, okay? The large enterprises will usually have BKI infrastructure and HSM hardware. Okay, cryptographic randomness is as simple as we defined it last week, is non-deterministic physical randomness. Okay, so you need to generate it through hardware, and there is a dedicated hardware devices, usually a large organization, usually for PKI, public key infrastructure, HSM, to generate and manage the keys of all types. Okay, and usually this will be integrated with core systems. So, for example, if you have a core banking or a billing system, core banking in a financial organization, or a billing system in a telco infrastructure, you will have your HSM to generate the keys of all types and distribute the keys and manage the life cycle of the keys. So it's generated usually using hardware, so you don't have any problem. And this will be integrated with your core systems. And in this case also, you will have no problem. Okay. And the main point here is either you have new HSM keys using quantum random generator or old HSM keys using a true random number generator. It is based on non-deterministic physical security in both cases, so you are okay, right? So far so good. But whatever smaller application, like the code examples that I showed you from legacy code. In legacy code or a smaller system, usually because of the lack of the governance and best practice for software engineering, developers tend to generate the keys using SDKs or software, the pseudo random number generator. So part of the static code analysis as well, you will find something like that. So instead of your Arise organization and have very good public key infrastructure and HSM module generate a real cryptographic randomness keys, okay, but it is not used in all your systems. It might be used only in the critical core systems, but not all your systems. So if you find one system of those actually with sensitive data, you need actually to change this immediately. So this is why we included the part of cryptographic randomness in the fourth module. This was the reason, because this is not related specifically to quantum cryptography. No, this is related to cryptography in general, but it is very important to test it actually. Otherwise, you will have some holes, because if you remember, if you have a pseudo random number, okay, unpredictable, okay, it will look randomly perfect, 100%. But if anyone knows the seed, can get the key, as you remember. Okay. Then after this, actually, you develop the master plan and budget. Where is the budget here important? Okay, master plan means time and cost. Okay, this plan actually will be based on the risk assessment. You have a risk model, you have cryptographic bill of material now. Okay, you have 1,000 assets, you collected 500 of them, and you calculated risk scoring actually, and you prioritize that 50 of them are critical. You put this in the plan actually in the short term, for example, and you put some estimate. Here is by the tricky part. That's part of, this is why also this is a critical or complex migration project, because actually the different scenarios that we discussed, legacy code, open source stack, commercial black box code, okay, different type of budgets and different types of rectification and migration and upgrades. So you need actually do a phased migration budget estimate for every time of effort. A lot of work, by the way. With phased migration, of course, this hyper migration comes in, and also the revelation with vendors. So developing this migration plan, this is very, very important. I need actually to have already reached all these conclusions, understanding what is EgQCC actually is all about, what is the different approaches, what I have, what is the risk, what is my data, what is the technology stack that I have, okay? How my keys are generated, is it random or not? What are my cryptographic algorithms? What are my tools and protocols that I'm using, okay? What are a vendor or commercial product or open source or legacy home developed? So a complex migration plan. Okay. Till now, I am doing just pilot, investigation, assessment, planning. Okay. Then start deploying the migration itself. Start with 2 or 3 actually critical assets, do pilot migration, hybrid, even if I have luxury to test something like UKD, okay, and apply also some architecture principle like zero trust architecture. This is also recommended actually to be included in my BQC migration plan. Is I am doing rectification for my architecture cryptographic infrastructure. So part of this actually do some modification where possible and move to zero trust architecture, and also modernize legacy systems and update key management as we discussed, and ongoing monitoring. Okay, this is the last slide, I promise. Just summarize in steps. This is actually summarize 1, 2, 3. Actually, what actually our target for this EgQCC quantum security track. To do this BQC migration, including starting with cryptographic inventory risk assessment, migration plan, and BQC implementation guidelines. What standard should I use actually? Should I use in my country and my organization? Should I use NIST or use European standards or customize my own? Okay. And also select the hybrid deployment on the architecture framework to integrate classical and BQC during the transition, either in cryptographic algorithm or the cryptographic infrastructure like hybrid proxy layer. Then drafting the budget, cost analysis, software, hardware, training, downtime, services, everything, and training. Training, very important. By the way, the training actually, this is what we are using in our track, covering the all prerequisite information for transition to quantum safe future or quantum resistance. Okay, and also updating the policies, because as you have seen, actually there is a lot of standards everywhere. Every country or every region in the world actually started publishing their national quantum strategy. Some of them couple of years ago, some of years in ongoing, and standard cryptographic standards updating frequently. So we need actually to keep updated policies based on our regional and local regulations. The typical timeline to get an understanding, and this is why, again, hybrid approach is very critical, because short term, 1 to 3 months inventory risk assessment. So this is not a trivial or small project, okay? Mid-term pilot migration deployment, this is something like almost 6 months, okay? Long-term full migration, if I am lucky, I can do it within 1 to 3 years. So that's why, again, it is very, very important to start with hybrid approach to close the immediate threats. So this more or less summarizes the objective of our EgQCC quantum security track, okay? To be prepared actually to start this engagement, because this is very, very critical, and of course extremely critical actually everywhere in the world. That's it. Now I'm open in the last 5 minutes to any questions.
So one more question, please.
Sure.
So regarding the methodologies, if we can go to the quantum threat, not the quantum threat model, I think there was
methodologies.
I think there was an Excel sheet, something like an Excel sheet with.
Yes. It will come now actually on the, hopefully, methodologies of quantum risk models.
Yes,
okay,
but
can you see
still
it?
it's showing the SAMeh sample cryptography bill of materials.
Yes, I'm not, because I'm opening also from my my mobile, so there is nothing shown now. Very
Anyway,
strange.
so regarding this, my understanding is that they are something like an assessment, but for different entities or something like different. So is there a setup where we need to run one of them, or we need to run all of them, or we need to run, what is normally the recommended approach, or what should we do?
No, actually, this is part of the regulations that we already discussed in the last two slides. Okay. When you start actually your DQC journey, you need to decide actually which one of this standard, for example, risk models you will adopt based on the sector that you are working on, based on your local regulation and the standards. So there is no one size fits all.
But we do not need to run multiple of them, so just one, or it depends on the
Uh, you,
regulation, of
you,
course.
you, you,
Yes.
you- no, you can actually you can run custom version.
Mm. Okay.
You can run custom version, by the way. I guess you can see now my screen. Yes, this is the one that you already. No, actually, I bought this also as example. There is maybe this is only 10 examples, very popular, but you can find also something like another 10 or 20. Okay. Uh, what you should do actually before you start, I personally selected only a quantum adjusted risk score, very popular. Okay. And I also selected customized version from index from IBM Quantum Safe Reddit's index, by the way. I selected this and this. Okay. So this was my customized version. Okay. You will find different standard and different countries with different regulation. So for example, every country you will have usually two things: quantum strategy and cryptographic standards. Okay. You will find some mentioning actually to what they prefer, but you will see some more detailed or fine grade standards. So in the financial sector, for example, actually they prefer a special type of standards, like for example, Isaac, for example, or post-quantum financial infrastructure framework. If I am bank, most probably if I am a bank in Europe, for example, I will try to use this first, okay, but will comply to the higher level standards. If I am telecom, I might use another standard, and so on. So this is a part of customization. So again, if you can see my screen, this is updated policies. Yes. Okay. This is 8 actually, updated policies. What standard I'm using for everything, okay, and ongoing monitoring, evolving quantum threats, list standard, annual policy reviews, and performance audits. So this is not static, not dynamic. You will not do it once and freeze it. No, actually, you will start it again. I want to take a chance for your question. Thank you very much for this very good question. During the last 50 or 60 years, cryptographic transition and cryptographic migration was not that fast. Every 5 to 10 years, something like that. Okay. But now, okay, or the last few years, actually, it is totally different scenarios. The speed of cryptographic evolution is very high. So you are starting now, actually, but you should be ready actually to update this maybe every month, every couple of months, every year. Okay. So this is a continuous effort. Okay. And you need to be ready and evolving all the time. So this is part actually of the exercise.
Thank you.
Okay, you're welcome. All right. I would like to thank you all actually for your participation, and would like to close with one thing, the tasks. If you can see here, we have 5 tasks for the 5 modules. Okay. I guess you can see the due dates. Okay. module 1 task, actually, this was the module 3 task, actually, due today, for example. Okay. And we have 16 turned on. Okay. We accept late submissions with maximum couple of days. So we need actually to be completed as soon as possible. Okay. We have module 2 actually due actually within 2 days. Okay. For the random number generation. Okay. We need actually to complete this. And the last task of today, I put it 2 weeks from now. Okay. This is 27 March. So you have 2 weeks. So please actually make sure that you all submit the 5 tasks. Okay. We accept late submissions for the first 4 modules, but actually the last date actually for everything actually will be 27th of March. Okay, this is very important because this is the graduation certificate or completion certificate. It is not just completion, it is certificate actually that you attended this track and you already performed this 5 tasks actually and graded and did actual work, and you are ready actually to engage in similar engagement. So this is very, very important for everyone to complete the 5 tasks. Finally, thank you very much for your attendance, and we wish all of us the best in our BQC journey. Thank you very much.
Thank you very much. Congratulations. Excellent course.
You are welcome. Thank you.